Hi, in this video I'm going to explore Monte Carlo method in very intuitive and simple way by utilizing two very simple examples. I provide the corresponding Python codes to help better understanding of the concept. In essence, the Monte Carlo method uses random sampling to solve problems that might be deterministic in nature but are too complex to be solved analytically or through non-conventional numerical methods. More specifically, when dealing with high dimensional systems, optimization problems, and so on and so forth. We can use the method for integration of high dimensional functions, which is the topic that I'm going to explore using simple and low dimension space in this video. To understand the Monte Carlo method, you'll need to have a grasp of the several key concepts and information such as random sampling, probability theory, and statistics. But here I'm trying to start with a more intuitive understanding of randomness and estimation. It is important to note before starting examples that the key to success of the Monte Carlo method lies in the law of large numbers. This law simply states that as the number of samples increases, the average of outcomes will converge to the expected value. This highlights how the accuracy of estimates in this method is controlled by the number of random samples. There are some disadvantages in using Monte Carlo method. For example, small sample sizes can lead to high sampling error that, on the other hand, will cause the estimates to be less accurate. In some cases, the convergence of the method to the exact solution is very slow and needs then lots of sampling points. Let's explore our first simple example without any further detailed considerations. The first example is about estimation of the area of a circle with radius of 1 or diameter of 2. We use Monte Carlo method by generating random points within a bounding square. We first bound the circle by this square of length 2 centered at 0, 0. We then determine the fraction of points that fall within the circle with respect to those fall within the bounding square. Let's dive into it. In short, the basic idea is to generate a large number of samples within this square and use statistical properties of these samples to approximate the area of circle. We have here two axes, x and y, within the range -1 and 1. The black circle markers here show how these random pairs are distributed within the area of bounding a square. Now we count the number of points that fall inside the circle. In this step, we calculate the distance of each generated random pair xy with respect to the origin 0, 0 using this equation. If this distance is less than or equal to 1, the point falls within the circle. We are now ready to estimate the area of the circle using Monte Carlo method. If we increase infinitely the number of sampling pairs or points, we know intuitively that the area of circle to the area of bounding a square is equal to the number of points within the circle to the number of points within the bounding square. In this relation, the area of bounding a square with length of 2 for each axis is 4, and therefore we can easily estimate the area of circle using this relation. Here I further present the Monte Carlo method to estimate the area of our circle using following Python code. Let us start our second example that we aim to use the Monte Carlo method to estimate the integral of the function y equal x squared within the interval 2 and 4 as shown in this figure. I try to follow the same steps as I did in the first example. I first define the bounding box as shown here. That is a rectangle containing the area of interest. Like before, and part of the key idea behind the Monte Carlo method, I generate a large number of points within the bounding box. These points have two coordinates, x coordinate between 2 and 4 and y coordinate between 0 and 16 as shown here. For each generated pair xy, we calculate corresponding function value y equal x squared and then count the number of generated points that fall under the curve y equal x squared. That means all y less equal x squared. Now we are ready to estimate the area. Similar to the first example, To estimate the area under the curve, we use intuitively the fact that the ratio of points under the curve to the total number of points within the box multiplied by the area of the bounding box provide us the area under the curve. Again, I further demonstrate the Monte Carlo method to estimate the area under this curve using following Python code. Remember that the accuracy of the estimate in both examples is controlled by the number of generated random points.